perfect. So welcome everyone. My name is Michaela Resch and I work with MnDOT's Office of Research and Innovation. And we would like to welcome you to our first ever Lightning Talks event. We are so excited to share some of our cutting edge winter research projects with you. Today we have 5 presenters who will give a 5-minute talk about their research project. And then we will have time for questions and answers at the end. So if you have any questions throughout the session, enter those into the chat box and we will make sure to get those at the end of the session. So today's session will be recorded. For those who cannot attend, if you have enabled your camera during the session, the recording may include your image, which is private data under the Minnesota Government Data Practices Act. You are not required to allow MnDOT to use your image and there are no consequences for declining to do so. To opt out of the recording, simply turn off your camera. All right, so before we get started, I have a couple of announcements from our office. We are currently accepting research project ideas for our annual academic research solicitation. They are due on March 15th, and you can submit your idea by visiting IdeaScale, or you can get to that link by visiting our website homepage and accessing it there. Secondly, we hosted a webinar on January 13th with information on how to get involved in MnDOT's research program. If you missed that event, a recording is available on our YouTube channel. And now I will hand it over to Sue Lodell to provide a welcome from MnDOT's Office of Maintenance, our partner for this webinar. Sue, are you on the line?
I am here, and good afternoon, everybody. You know, it's hitting 40 today here in the Twin Cities, so enjoy the weather. We want to thank the Office of Research and Innovation because really this was their idea to focus on the Office of Maintenance and winter research first for this lightning round. So I hope it's well received, and I want to thank all the participants that are here, and I know that we have quite a few external participants also, and I believe a lot of them are from our Clear Roads pooled fund that we belong to, so I hope you enjoy. Winter maintenance research is especially important in this state, especially in Minnesota, so this is very timely. I would say about all research that's done in this winter maintenance area is always trying to focus on the balance between safety and the environment, the long-term effects of our climate, how we can do our jobs more efficiently and effectively. And I think these 5 projects will highlight most of those areas for you. So, as you know, within the Office of Maintenance, we have a much smaller research program, and we're very lucky to have that. I just thought I would mention it in case other entities are interested in hearing more about it. It's a real small feet on the ground research for our field workers. So here at MnDOT, we go for research and innovation. So please enjoy the afternoon.
Thank you, Sue. Thank you for that. So getting started with our presentations for today, we will have Max Donath from the University of Minnesota presenting on his project, Implementation of Lane Boundary Guidance System for Snowplow Operations. Get us started, Max.
Hi, good afternoon. I'm going to be talking about deploying a new improved system for seeing the road in whiteout conditions. I'm not able to control the slides or move my cursor around, so Michaela will click forward, if you will, and I will let MnDOT staffers introduce what we're doing. So Michaela, next, there we go. Chase Fester will start the introduction.
In Southwest Minnesota with the heavier snowfall events and wind, you know, as you're plowing snow, a lot of that snow is coming back over the plow and back on the windshield, reducing your visibility.
This one is just an easier version. We want something basic. There's enough stuff for the driver to look at that we wanted just something that would make it easier for the driver, that he could glance and look to see if he's right or left of the line. It's an aid for him. Otherwise, you're hanging onto the steering wheel and hopefully you're going down the road straight.
It works fantastic. The drivers really like it. We've actually asked for more for other trucks to be installed in. We have very good positive feedback from the whole system.
If I can have the next slide. Essentially, what Bruce Thompson and Tony Johnson were talking about was a newer version that we developed and deployed on Minnesota Highway 25. That system costs considerably less than the very first system that we developed about 10, 15 years ago. That system way back when cost on the order of $60,000, $70,000, and we've significantly reduced the cost since then with this newer version. What the operators identified to us with the version that was running on Highway 25 was that the brightness of those little LEDs were causing problems. They were just too bright at night, too bright at dark, and they couldn't control them. And I'll tell you a little bit more about that shortly. And the other thing we were asked to do was add hazard detection. And so that's what we did with this newer version that you'll see a little bit about today. If I could have the next slide. This newer version essentially still has a differential RTK GNSS system. We are picking up correction signals from the what's called the mndot core system, a continuously operating reference stations. There are about 100 plus reference stations across the state of Minnesota that will provide us with accuracies on the order of a few inches. We've reduced the cost of the computer. We're now using a Raspberry Pi, which you can buy at Amazon for under $100. So we've brought the cost down quite a bit. But I tell you something, the Trimble receivers that we're using are still very pricey. But we've recently tested and evaluated a newer system that cuts the cost of that by 75%. If I can have the next slide, please. These are the components of the systems that were being run on Minnesota 25. You can see, I can't control the cursor, but on the upper left, you see an antenna from the GNSS receiver. The LED displays on the dash in the lower left. And the yellow box on the right, that's that receiver. If you went out and bought it today, that would cost you $16,000 for that little yellow box you see there. Trimble wants to get paid for their technology. And I want to let you know that we've evaluated a competitor to Trimble, and we find that it's just as good for about $4,000. So we think we can drive the cost of everything down quite a bit. If I could have the next slide, what you're gonna, if we can click that again, you're gonna see LED operation. These are different colored LEDs and different shapes. The green represents being in the center of the lane. If you move 1 foot over, different LEDs are triggered. So each LED represents 1 foot of lateral movement. The truck is now going to move over into the opposing lane. And you can see that the driver is being warned that they're in the opposing lane and they drive back into their own lane. The thing is, if I could have the next slide, color is a huge deal, and different colors have different effects depending upon ambient conditions. For example, green is uncomfortably bright compared to red at night, but during the day, green is too dim compared to the brighter red. So at different ambient light conditions, different colors have different effects, and the operators wanted one knob, but we can't just fix it with one knob. So we developed a series of experiments with human subjects, literally a black box where we enclose people in different ambient light conditions to see how they reacted to different colors. And we developed some equations, if you will, that we programmed into our computer. So we controlled each color independently of each other color for each LED, and we would change it depending on ambient conditions. So it would be different at night and different during the day. and the operator had only one knob that they needed to worry about. So that worked really well, and we've deployed that in the system that we're evaluating now on 4 different plows. If I could have the next slide. There are 4 plows deployed now, 1 in District 7, 1 in District 4, 1 in the Shakopee area, and 1 in Dakota County. On the upper left, you'll see a radars mounted on the L bracket. The 2 antennas are on the side. Just below, on the left, you see the new LED display. And besides these colored LEDs at the bottom, there are 3 bars that essentially represent whether there's a hazard on the left, in the middle, or on the right lane. On the right side, you'll see that operators sometimes want the display up near the dash instead of up near the sun visor as opposed to being on the dash. And we customized it depending on what the operators wanted it. I don't have a lot of time to show you any demos, but let's go to the last slide, which is a video of a truck. And if you can click forward, in District 7, here's an example of the flat roads we have in Minnesota, flat as a pancake. And there we go. And cars in the opposing lanes show off as red lights in the bar on the upper left. If there was a car in your lane, it would show up on the middle bar. And if a car on the right lane, it would show up on the right bar. I'm not sure why that video isn't moving. Could be some Wi-Fi problems, bandwidth. Did we lose it?
It played through on my computer. I can play it again if you'd like me to.
Could you?
Yeah.
What you're only going to see is bars on the left. There are no stalled vehicles on the right. If there was a stalled vehicle on the right, then not only would we have the lights turn on, but we'd have all sorts of sounds generated, again, to catch the attention of the driver. Again, this is a clear day, no snow, so it doesn't look like much, but the idea is imagine whiteout conditions, and the driver better stop before he hits a stalled car. Anyway, that's where we're at. If you want any more information, more than happy to answer it at the end of today's session, or you can contact me separately. Thank you very much.
Thank you, Max, for that wonderful overview. If any of you have questions about this new hazard warning system, make sure to get those in the chat box now, and we'll get to those at the end of our session. So our second presenter today will be Will Northrup, also from the University of Minnesota, and he will be presenting on reducing winter maintenance equipment fuel consumption using advanced vehicle data analytics. All right, Will?
Thanks, Michaela. Can you hear me okay?
Yes, we can.
Okay, excellent. So yeah, thank you everybody for attending. This is a really nicely attended event, so I really appreciate the opportunity to talk about our project. I'm going to give a presentation on behalf of my research team at the university, including Pete Ringa, Sean Haig, Haoming Lee, and Rupita Chenshu, who are both at the end graduate students there who are doing a lot of the interesting work on this project. So next slide, please. So the whole purpose of our project is to use data that are being collected from snowplow vehicles currently. So MnDOT snow and ice removal consumes over 1 million gallons of diesel fuel per year at a cost to over $2 million per year to taxpayers. Right now, on board each snowplow, there are what's called Maintenance and Decision Support System, or MDSS, controllers that are collecting data about snow and road conditions, implemented in about 600 snowplows in the fleet right now. They use a mobile computer that's been designed by and implemented by a local company called Ameritrac. So in fleet management generally, there's a ton of commercial platforms out there to do what we call telematics. Often the data are way too much for people to handle. So fleet managers don't have the time to scroll through, terabytes worth of data to understand trends. So the purpose of our project is to interface with some of the data that are coming from these vehicles with the objective to reduce fuel consumption through detection of what we call spatiotemporal locations with high fuel use. So spatiotemporal just means in space and time. So the idea is that we will interface with data that comes from the snowplow in order to detect certain features about the roadway through the data that we're collecting. Okay, next. So as part of our project, we're using the data to identify certain areas and times where fuel consumption is high. One of those particular areas is in the issue of idling. MnDOT and NPCA have goals for reducing idling in vehicles and reducing CO2 emissions, respectively. So idling is of key importance and is considered low-hanging fruit in the fleet industry for reduction of CO2 emissions and fuel consumption reduction. So right now, externally, MnDOT reports about 29,000 gallons of fuel consumed in idling in the 2017-2018 timeframe. If we define idle as being where the RPM of the engine is greater than 0 and for greater than 3 minutes with 0 speed of the vehicle, we can identify from the data that we're collecting the times and places where idling is occurring in the fleet. So we've collected this data we've collected a number of different data from different winters, but from 2018 to 2020, in the 19 season, we've collected a partial fleet from this season. We found that about 4.5% of fuel consumption is during idle periods of the vehicles. So they spend about 4.5% of all the fuel burned is during idling. So essentially vehicles sitting there. Right, and while some of that idling is necessary to keep the vehicle warm or in stoplights or other places where they might have to be stopping, but that's a considerable amount of actual time is spent at idle. Almost 25% of total time that the vehicle is on is idling. So not only did we determine this from a kind of a global perspective, but we also looked at individual depots where a lot of the idling occurs. And up on the right-hand side, you can see a figure where we've identified idling events over a course of a season where, these different places represent idling times greater than 5 minutes. And we've also done for minutes, 3 minutes plus or 20 minutes plus, sometimes 30 minutes. Some of these vehicles are idling. So this is obviously an area where we can identify where idling is occurring and help the fleet manage where to reduce it. Okay, next slide, please. Okay. Another thing that might seem obvious to most folks is that that as you have more snow, you get more fuel consumption because the vehicle has to push snow around. And we use our data to sort of loosely confirm this. You can see that the scatter plot on the right is showing the miles per gallon average of the vehicles as according to mean snowfall. Of course, lots of things happen to make this occur, so that's why the scatter is pretty big. But we considered only high activity days, meaning like days where considerable snowfall was there, and also district aggregated weather observations. So really that we see that we can show that if there's more snow, then there's lower miles per gallon. Now, what's interesting is that we can actually use these data to, and we can use this information that snowfall increases fuel consumption to look at specific locations where snow is highest. So you can go to the next slide, please. So MnDOT has also already categorized some areas where there are snow traps, where there's excessive snow. We can actually correlate fuel consumption with the snow trap locations in individual vehicles, such that we can identify what fuel is consumed during the snow trap areas. And though we're working on this right now, we don't have exact quantifiable numbers as to what the increase in fuel consumption is due to snow traps. We can categorize that, or we can do the reverse, which is we can use the fuel consumption to figure out where snow depth is high. And so this is like something we're working on towards the end of our project with the current winter data, though we haven't had much snow in Minnesota this winter, too many snowfall events, but I think we can still get something interesting out of it. And winter's not over yet, I'm sure. Yeah. So anyways, yeah, so I think that is all I had for this project to keep my talk short. So I think you can hit my last slide. I'd be happy to answer any questions at the end, and my contact information is here, as well as I'd like to recognize our project coordinator, Thomas Johnson-Kaiser, and Joe Haneke, who is our MnDOT champion of the project. So thank you very much.
Awesome, thank you, Will. Moving on to our third presentation today, Jeff Meek from MnDOT will be presenting on Have Minnesota's Warmer Winters Increase the Number of Freeze-Thaw Cycles?
All right, thank you, and good afternoon, everyone. So as Michaela mentioned, Jeff Meek with the Office of Sustainability and Public Health here in MnDOT. So just, Michaela, just a heads up, we're not seeing the slides. Okay,
yeah,
good.
Sorry about that. It looked like
no problem.
Something happened with the sharing. Okay.
Yep, it's back up.
Okay.
So this is just a quick map to give you some context on how much winters have changed in the last 50 years. Each decade is increased 1.5 degrees. And Michaela, just a heads up, I'm getting a little bit of feedback. I don't know if other folks are. Okay, I think that, yeah, it looks like it might be better now. Okay, yeah, I saw others had that issue in the chat. It wasn't just me. Thank you, Joseph. Yeah, so you can go ahead and go to the next slide. So this question about have Minnesota winters warmed, there's a moving image here to give you a little context of how has this affected freeze-thaw cycles. So this is the question. I focus primarily on climate resilience and climate adaptation in MnDOT, and as you look at this graphic on the left, you can see how much warmer it's gotten. So this is the running average, 30-year running average of the winter lows. So this is, you know, -11 is the average low in the top of the state. You can see there, and the dark line in the middle is the 0-degree contour line. You know, and like you can see the last 30 years, that contour line jumps up pretty fast. So this is just pulled from the DNR, the Minnesota DNR's website, climatology office. The average 0-degree winter has already moved up a lot in Minnesota, and this has kind of led to us asking some questions. What does this mean for maintenance of roads and stuff like that? So next slide, please. And so I've heard anecdotally, I think most of us have, that we're seeing more freeze-thaw cycles and potentially more damaged infrastructure as a result of that. And so there's some questions on, well, can we get some data to back that up? And so one of the reasons this is of interest to us is related to the impact on the roadway. So there's just a few images here you can see, but with more freeze-thaw cycles, the water expands, contracts more frequently, and that will result in it'll accelerate the pavement degradation. And next slide, please. And so the overview of this research, really the focus of what we're trying to do, we're still in the middle of it. We're maybe a month or two from wrapping up this phase 1, but pretty excited to see what we're going to get from it. So have Minnesota winters increase the number of freeze-thaw cycles? Phase 1 is looking at a lot of that existing data. So mining the last 40-ish years of data that we have at the MnRoads, which is our research station, where we've got temperature gauges and freeze gauges, moisture sensors, all that stuff. And those are really important because what a freeze-thaw cycle is, how you define it and track it, changes depending on soil type as well as moisture content. Those are the two of the key variables, though they're not the only ones. So we've got really good data on air temperature, how that's changed over the last, say, 50 years. But correlating that to how long it takes certain pavement types and sub-pavement types to completely thaw and then refreeze will be really valuable for us to then quantify how those patterns have shifted. And so this is, we're working with Iowa State University and some researchers there, and you'll see their contact or their name at the end, to do some big data analytics using some algorithms and computing power that they have. And then phase 2 will be collecting that, I'll say, ground testing and evaluating the accuracy of those models that were created in phase 1 based on historical data. So, and we expect then phase 2, we would basically kick it off this summer. So by next winter, we're getting really good data and can validate the models and see whether or not this applies in other parts of the state. Because in other parts of the states, we may have different soil types and the weather data will be different. And so right now, since we're just basing it off one site, we don't necessarily know the applicability throughout the state. So that's the extent of this research project and kind of where we're at. I'm of course happy to answer any questions. And next slide, please, Kayla. Yeah. So here's my contact info, and then as well as the name of our the principal investigator from Iowa State. Yeah, and I'll stop there.
All right, thank you, Jeff, for that overview. That was really interesting, and I'm sure we're going to have a lot of questions at the end about your project. So our fourth presenter today is Rob Chaussier with MnDOT, and he will be presenting on his project, Can Automated Vehicles See in Minnesota Ambient Particle Effects on LiDAR Systems? Rob?
Good afternoon to everybody. My name is Robert Chaussier. I work in the Office of Traffic Engineering at MnDOT. So in the beginning, as you know, connected and automated vehicles is a popular theme and topic throughout the United States, probably throughout the world, that is too. So the CAVX office was started a few years ago. I think it was spring of 2018 at MnDOT. And they created this CAVX challenge to introduce different projects for connected and automated vehicles. And part of that challenge was this project that we're looking at right now. And the University of Minnesota is the one that was awarded the research on this project. And as you know, Minnesota has a lot of different environments for testing connected and automated vehicles, because we have just about every type of precipitation here in the state, to include agricultural dust, or if you're in the farming area, you know, you got the thrashing of the crops and all that kind of stuff. But they also have township roads with a lot of dust on them as well. Okay, so if we move on to the next slide, you'll see all the different people that are involved with this project at the University of Minnesota research team. And thanks to Lou, he's been the provider for a lot of the information in this presentation. In the middle there, you'll see all the people that at MnDOT that are associated with this project. And then on the right, you'll see the partnerships that we have with VSI Labs and Luminar Technologies, which is the maker of the LiDAR systems. Next slide. So as I stated, Minnesota's got all these different types of environments and types of precipitation. And all the suspended particles that we have in our environment has a different have different properties. So if a light hits this particle, it's going to have different detection, okay, and it's going to have a different backscatter of that signal from the laser. And then you can see there that the images right there on the bottom of the slide kind of shows you the little bit of what the camera sees on the instruments that we use, both in the normal and in the obstructed environments. And next slide. So what are we doing? As you can see, the top left is the chamber. The top right is the car that we use for the two different types of experiments. The first experiment is the inflated chamber, which is installed at a lab at the University of Minnesota. And what they do is they have a machine that suspends known particles into the air in the chamber, and then the instruments are used to sample and measure the particles. And then the LiDAR is placed in position to determine how the different particles affect the signal. And as you can see on the lower left there, that's an image used from the chamber. And then for the second experiment, it's outdoors. And all this is done locally too, where there's one lead vehicle that's got a mounted, roof-mounted opacity instrument. And then there's the following vehicle, which is equipped with a LiDAR sensor on the roof. So the lead vehicle measures the concentration of the particles, and the following vehicle is behind that vehicle, and then the LiDAR images that are used in that following vehicle, they're examined for whatever we're trying to do there, and what the impacts of the systems are. So if you go to the next slide. So what do we hope to learn? Well, I guess the university would say that we're trying to do this to determine better practices so that we can get a better model, so that we can train, we can educate our students better. But if we go in a little bit even farther than that, we hope that it cultivates better experiences on the road for anybody that's in an automated vehicle, to include maybe regulations, policies, and safer systems that we use. And that probably sums up that. And if we go to the next slide, you'll see that the timeline here, we're about midway right now. So right about in the middle of that timeline arrow, we're not too confident that we're going to get a snowstorm by March 1st. One that's going to dump enough snow that's going to give us the adequate readings on those different tests that we do. But maybe sometime in March it'll happen. I know that some people would not like that to happen, but for our test purposes, we would like to get some substantial snow so that they can go out there and do the on-road test. So that concludes my portion. I suppose if you have any questions later, we'll entertain those questions.
All right, thank you, Rob. It sounds like a common theme with today's projects is that we need a little more snow in Minnesota to get them done. But our fifth and final presentation for our webinar today will be presented by Dan Gullickson with MnDOT, and he is presenting on the project promoting the adoption of snow fences through landowner engagement.
Dan, you're muted. Thank you. Good afternoon, everyone. Thanks for the opportunity to be here today to share with you the research project looking to promote the adoption of snow fences through landowner engagement. This project looks to see how we can better work with landowners when we have blowing and drifting snow problems across our southern and western parts of our state, where we literally can't put a fence along our right-of-way to contain the amount of snow. Here we have Trent Robbins, our blowing snow control shared service designer from Mankato, along Highway 60 near Windham. And we have that snow fence set back about 150 feet into the farm field. And by looking at this photo, you can see that if we tried to place this fence in our right-of-way, we'd be basically burying the road with snow. And that's where it's really important for us to have an opportunity to engage these landowners and work with them so that we can place these things in the right spot. Next slide. So what is the issue? Issue on the left there is it's a safety issue in terms of visibility. Oftentimes there's numerous vehicles that will go off the road and they're going to be stranded and may need to be rescued or pulled out of the ditch. Other times there can be more serious incidents where there's crashes and the severity of the crash may cause a lot of harm to people. So the idea here is to try to improve the road surface conditions and the driver visibility so that they can more safely get to their destination. And then the image on the right, we're looking at the where we have to go into these snow traps and have to, blow them out and then have to go in and do traffic control like we see here. That's a lot of fuel that's being consumed in areas like that. It's not only the equipment that's opening the road up, but the equipment that is doing the traffic control for the safety of the traveling motorist. And then there's also looking at where salt is having to be applied. And a lot of times you can have wind events that occur, for several hours, maybe as much as 24 hours after snowfall. And that's when deposited snow keeps coming across the road. And so we're looking for opportunities to improve the safety and mobility of the traveling public. Next slide. So what are we doing? Through working with the University of Minnesota Center for Integrated and Natural Resource Management and the University of Minnesota Extension, they actually went out and interviewed 30 of our early snow fence adopters. And these are folks that have been doing snow fencing, whether it be standing corn rows, living snow fencing, or structural snow fencing. They've interviewed them to see, what was it like? What was your story associated with doing this? And we really wanted to hear from them to see how it impacted them. Next slide. We wanted to learn from them what motivated them. What was their motivation of becoming an early snow fence adopter? Were they adversely or positively impacted by the snow fence? Oftentimes we hear from landowners who have never done a snow fence and we approach them about it. They are concerned about that snowdrift that's sitting in the field and thinking that that may delay their planting in the spring. And so with this research project, we're reaching out to landowners that have been doing this and finding out, have their yields been adversely impacted? And this type of information will be very helpful for us when we're figuring out our compensation, whether we're compensating them through a rental agreement for having the snow fence out there, or when we're buying an easement to have the snow fence out there. It can help our right-of-way folks do their negotiations, and it will also help us better articulate when we're approaching a new landowner what they can expect. The other thing we want to get from this project is advice to consider, what advice would they give other landowners about adopting a snow fence? Oftentimes some of our best marketing is going to be farmer to farmer, sharing their experiences with one another and trying to learn from that. And as well as getting advice that could help us when we're designing snow fences to be better designers. Helping our maintenance staff. Our maintenance staff does a phenomenal job of recruiting farmers to leave standing corn rows each year. And we're close to almost 50 miles of standing corn rows across the state. And so there's going to be opportunities that we can learn how to better connect with our maintenance staff when we approach landowners about standing corn rows, as well as project managers and right-of-way folks that are going to be working with landowners on future highway construction projects. And then the other component of this research project is called Farm Maps. And it's a tool for tracking where we've deployed these treatments across the state, whether it be a living, structural, or standing corn rows. And oftentimes I get inquiries from landowners like, where have you done these before? And through the University of Minnesota having this Farm Maps collection, we'll basically have icons across the state where these fences are deployed. And that would allow a prospective landowner, farmer, to navigate, to look at some of these fences to see what they look like. And that may help them decide whether it's something that they would like to pursue. With that, we're probably going to be wrapping this project up here in November of 2021. A lot of the heavy lifting is happening between now and July 1st. And we're looking at doing some training after we get more of the results from these 30 landowners. We'll be doing some training with the University of Minnesota, virtual training, that you'll be something to be watching for coming up probably during the months of May and June to kind of learn how we can better work with landowners. Next slide. Thank you.
All right, thank you, Dan. I thought that first snow fence looked really familiar. It's right by my grandparents' house. I've driven by so many times. So those were our 5 projects we are highlighting today, but there is a lot more winter research going on. If you are interested in learning more, I would urge you to check out projects listed on our website at mndot.gov/research, the Clear Roads website, of course, at clearroads.com, and the Office of Maintenance, and you can access them at mndot.gov/maintenance. And it looks like we have about 17 minutes left, so we can start getting to some questions, and Shannon will help moderate that chat box for us.
Great. Michaela, before we start the questions, 2 things. I'm unable to save the participant list. I think you need to do so as an organizer. I think you only have the option to do so. And then the other thing is, if you are not attending from MnDOT and would like to receive a copy of this presentation afterwards, please put your email address in the window, because we're not sure if it'll come through in the participant list, but we should be able to have all the email addresses for state DOT employees. So if you put that into the chat at the end of this presentation, we'll save that for when we send out the webinar recording. Additionally, we'll be putting the webinar recording on our website, mndot.gov/research. So you can also look there if for some reason we miss you after the conclusion of this presentation. So we can now start with some questions. There were a lot of questions for Max Dunneth on the lane boundary guidance system. So first of all, this question is from Joe Mueller asking, how does the foreign object detector detect cars in the lane? Is it using radar to do so?
Yes, it is using a radar. We mount a radar on the roof of the truck cab, and we adjust the tilt of the radar so it is aimed forward, and it has a wide enough view that it can see 1 lane to the right and 1 lane to the left, as well as the lane is straight ahead.
Great, thank you. Another question from Bob Basic. How does the system pick up a car overtaking the plow from the rear and passing the plow? Or does the system pick up a car that's overtaking the plow from the rear and passing the plow?
No, it does not. It is not looking behind the truck. It's only looking forward. Again, the truck operator knows about where the truck is in the lane, but it does not have any control related to vehicles behind the plow.
Great, thank you. A question from John Huspany. Dr. Dunneth, the lane guidance indicators look like a great aid for whiteout conditions. Is MnDOT considering extending the technology into increased automation, such as unmanned plows someday?
Well, that's a decision for people like Sue Lodahl. I would say, if you think about the complexity of plow operations, we're nowhere close to unmanned driving. This is a very complex environment. You have guardrails on the right. You have protected lanes on the right, protected lanes on the right. You would need to have a lot more information in order to make decisions like that. And as the other presenter talked about, LiDAR is going to have serious problems in whiteout conditions. I don't think LiDAR will work there, but high accuracy GNSS works like gangbusters, but all it tells you is where you are. You better have a good map, and you need high accuracy maps, and we map the roads ourselves for our application.
Okay. Another question on the radar. How far forward does the radar see a car in the lane guidance project?
Several hundred meters.
Great. All right. Another question. Are the lane indicators scaled to the truck body, or are they keyed off of the edges of the plow when they're being used?
Each operator adjusts it themselves. Basically, the operator can see where the edge of their plow blade is on the right or the left, and we leave it up to the operator and how they want to adjust that green center. Each operator makes their own decision about how they drive. Many of them like to drive and actually clear the roads off the lane stripe in one pass, so when they come back, they see the lane stripe on the way back. That helps them make sure that they completely clear the road off of both lanes with one pass in each direction.
Thank you. The questions that were asked, Dr. Dunneth, was there any follow-up questions regarding anything he said? Okay. All right, we have a question for Dan Gullickson about the snow fence project. Dan, do the plowed ridges / berms from a fully plowed roadway, including the shoulder, create a man-made barrier that might discourage drifts from extending onto the roadway, or is that still too close?
Yeah, that's a great question. One of the things that we do as blowing snow control designers is we look at the PI of the road. You know, that's the shoulder of the road where it starts to hit the ditch inslope. And that PI of the road, we really want to keep that free of a plow berm, because if there is a berm that's cast there from the plow wing, that becomes a trip point for the snow to quickly fill up the road again. So keeping the PI, keeping the plow berms knocked back and pushed down into the ditch is key to helping that wind blow through without tripping. And, you know, in terms of, you know, working in our road ditches, in terms of windrowing snow in the road ditch, that can definitely add capacity for future blowing snow events to hold snow in the ditch. But oftentimes we find ourselves working with the farmer to windrow snow in the farm field, create ridges out there that will trip that snow further away from the road. And so windrowing of snow is effective. In order for you to do it, you got to have snow to work with. But it's really important, though, to keep the not have a plow berm from the plow cast right at the PI of the road. That's just really detrimental. It'll create future snow problems and drifting issues.
Great. Thanks, Dan. Do we have any other questions from the audience about any of those two projects or the other projects? All right, well, seeing that there's no other questions, I think we'll conclude this webinar, but we encourage you to definitely reach out to any of the presenters if you have other things you'd like to know. And then Michaela will be sending out a link to all these projects. You'll be able to subscribe to them to get alerts at the end of the project when it's done. So you can stay tuned on what's going on with each of the projects that way. If you have any questions, also, please reach out to our office. We'd be happy to help you. Thank you. Michaela, do you have anything else?
Nope, that's it. Thank you all for attending our webinar today. It's our first ever lightning talks, and we had some really wonderful presentations from our technical liaisons and our principal investigators that joined us. So thank you again for sharing your time with us. I know a lot of folks are interested in this research. And as Shannon mentioned, we will send out those resources and a recording link to this event when it's ready. So that's all for today, and hopefully you join us at our next webinar.